H.C. Verma, Wave Motion and Waves on a String, Question 3. Here is the figure. A triangular wave pulse is shown on a string. At time t equals 0, the peak of the pulse is at x equals 10 centimeters. The pulse has a base from x equals 0 to x equals 20 centimeters and a height of 2 centimeters. The pulse moves to the right with a speed of 10 centimeters per second. Here is the question. Figure 15e1 shows a wave pulse at t equals 0. The pulse moves to the right with a speed of 10 centimeters per second. Sketch the shape of the string at t equals 1 second, 2 seconds, and 3 seconds. The key concept is that a wave pulse travels without changing its shape. It simply shifts in the direction of propagation. The distance shifted equals speed times time. Since the speed is 10 centimeters per second, in 1 second the pulse moves 10 centimeters to the right, in 2 seconds it moves 20 centimeters, and in 3 seconds it moves 30 centimeters. Now let us see the solution visually. At t equals 0, the pulse peak is at x equals 10 centimeters. At t equals 1 second, the peak shifts to x equals 20 centimeters. At t equals 2 seconds, the peak is at x equals 30 centimeters. And at t equals 3 seconds, the peak reaches x equals 40 centimeters. Notice how the triangular shape remains exactly the same, only the position changes. The correct answer, at t equals 1 second, the peak is at x equals 20 centimeters. At t equals 2 seconds, the peak is at x equals 30 centimeters. At t equals 3 seconds, the peak is at x equals 40 centimeters. The shape remains a triangle throughout. Tips. First, a wave pulse translates without changing shape. This is the key idea. Second, distance equals speed times time, simple but often messed up in unit conversion. Third, the pulse shape is determined by the initial condition, not by time. Fourth, always mark the peak position at each time on the x-axis for clear sketches. Like and subscribe for more H.C. Verma solutions at MAGPIEHUB. See you in the next video.